Okay, we're going to take a look, just a little example of chains of reasoning and how we sort of build up a chain of how we do things and so on. And just as an example to help you sort of develop the idea. So here's a very typical question down here. And we've got to use all our angle rules to figure out how we're going to find this angle here. Okay, that's the unknown that we need to find. So how are we going to do that? Well, let's see what we know. We've got, this is an exterior angle, and we know that exterior angles are equal to the sum of the two opposite interior angles. We could go that route. As long as we can find these angles here, we're okay to do that. So this one, I can find these angles because I can get this one here, because I know that this is an angle on a straight line, and I know that angles on a straight line add to 180. Now, how do you write it? Well, I've got to name this angle. So BCE, BCE. And then I do my 180 minus 135, which is 45. So it's 45 degrees. Now I got to give the reason. Well, the reason is that angles on a line equal 180 or add to 180. So I've got to give the reason, I've got to state what it is, and I've got to give a reason. Okay, that's good. Now, that's not enough information, right? I need to also know what this angle here is. So we've got this other property of angles around a point, right? They have to add to 360. So if that's 300, then angle BEC, this one here, is going to be 360 minus 300, which is 60 degrees. So I've got this to be 60 degrees and this to be 45 degrees. So I need to write all these steps down as I go, right? So there's my BCE, it's 45 degrees because of angles on a line equal 180. Then I do angle BEC, which is 60 degrees, angles at a point equal 360. And then I can do the exterior angle. So theta, which is going to be 105, because if you add these two together, you get 105, right? That missing one is 105 degrees. Now, the reason? Well, exterior angles of a triangle, and you'll notice that we do this with symbols. EXT, angle symbol of a triangle, is equal to the sum of the interior opposite angles. So that's a fairly substantial statement. Some people forget about that, and so what they do is they go, okay, well, I could find this angle here, and I know this angle, and I know this angle, so I know that they all have to add up to 180 because angles in a triangle add to 180, and then I could do this one because this is, again, another angles on a straight line add to 180. So I could work that way as well. You're trying to be as efficient as you can, but that's just a chain of reasoning and giving the